as well as the frequency. Next one is chopper. Chopper is a circuit that converts fixed DC to variable DC. Okay. Now inverter example is you will find inverters in the case of lifts. Okay. We can change from one store to another store style using the lifts, right? Inverter is used for controlling the lift there. Now chopper. Chopper is a circuit that converts fixed DC to variable DC. Next, cyclo converter. Cyclo converter is a circuit that converts fixed AC to variable AC. Okay. Here, the main function of the cyclo converter is to change the frequency. But we can change both magnitude as well as the frequency. But cyclo converter is used mainly for changing the change in frequency. That's why it is called as cyclo converter. Okay. What do you mean by cyclo converter? What is meant by cyclo converter? Harika, tell me what do you mean by cyclo converter? Harika. Okay, you are there.
Yes, sir.
Yeah, tell me what do you mean by cyclo converter?
Converts, which converts voltage and frequency into AC form.
Input is AC, output is also AC. That's what I'm saying.
AC.
Okay. Okay, good. Okay. No, okay, good. Keep on mute. Now, can you see the presentation, everyone? Can you visualize it?
Yes, sir.
Okay.
Yes, sir.
Cyclo converter is a device which converts fixed AC to variable AC. But the main function of the cyclo converter is to change the frequency. Inverter I want to use where I want to control the AC. Okay, but cyclo converter main. Okay, if you look like this, inverter and cyclo converter looks like the same, but inverter main function is to change the magnitude of the voltage. But cyclo converter main functioning is to change the frequency. The functioning of the cyclo converter is different from the functioning of the inverter. Okay, with inverter we can change. Input is AC, fixed AC, output is variable AC. Variable AC in terms of both magnitude, we can vary AC in terms of both magnitude as well as the frequency. In the case of cyclo converter also we can do the same thing, but functioning is different. Okay, next one is AC voltage regulator. AC voltage regulator is a circuit that converts fixed AC to variable AC. Here I can change only magnitude, not frequency. Input frequency is same as output frequency, output supply frequency. But what I can do is I can change the magnitude of the voltage. Example is AC voltage controller or AC voltage regulator. Example is fan regulator. Okay, where I want variable AC. Variable AC doesn't mean that variable frequency I want, just fixed frequency but variable voltage. Got it? Next, you can find applications. Now, this figure gives the broad idea where I can use. If you find, you will find number of examples. You can find here in y-axis in terms of capacity, power capacity. In terms of from 10 watts to 100 megawatts power you can control. Now voltage also, if you see that operating frequency from 10 Hz to 1 megahertz. See that you can find applications in washing machine, air conditioner, refrigerator, TV. Okay. Next you will find switched power supply, electric vehicle, robot welding machine, control motor, uninterrupted power supply. Now, train traction, you can find HVDC, as I said, no, HVDC, high voltage DC transmission. You will find number of applications. Okay, now, don't feel that this is limited to a certain applications. Wherever we require reliable power control, wherever you require efficient power control, wherever I require power control in a more reliable manner, then we need to go for which technology? Nothing but power electronics technology. Okay. Now I will tell you. I will ask you simple questions so that we can better understand the importance of the power electronics. Here I have a question for you. For example, in our fan, let us consider a fan in our home. If I keep the fan regulator at position 5 and position 1, there are two cases, position 5 and position 1. Under which case power consumption will be more? Keeping the fan regulator 1 or keeping the fan regulator position 5, or at any case power consumption is almost same. Power consumption will be less in which case? Anyone?
5, sir. Position 5.
In position 5, power consumption is more or less?
Less, sir.
Less. Okay, position 5. Any other answer? Any other answer?
Same, sir.
Same. Okay, same.
Yes,
Some
sir.
of you said the answer as same.
Same, sir. Same.
Same. Any other answer? Any other answer? Any other answer? Any different answer? Power consumption at position 5 is more, or at position 1 is more, or at power
Same.
consumption position same? Any other answer?
At position 5 is more, sir.
Position 5 is more. Good. Next, any other answer? Power consumption is more or less, you tell me. Just one and 5. Position
5 is more, sir.
Okay. Good. Good response from your side. Here I will tell you one important property of type of load or pump type of load. Keep unmute your. Okay. Here I will tell you the function, important property of a fan type of load or pump type of load. The property of the fan type of load or pump type of load is torque is proportional to the square of the speed. What is that? Torque is proportional to square of the speed. Means when the load means nothing but torque is nothing but the load. Load acting on the fan is directly proportional to the speed of the fan. Now you have done the brake test in our laboratory. Okay, you have done the brake test on DC shunt motor. You have done the brake test on DC compound motor. How you are increasing the load here? What type of load you are connecting to the motor? Brake test. Anyone?
Mechanical load.
Mechanical loads. But what type of mechanical load? It is a belt mechanism. Okay, belt load you are connected. By tightening the belt, you are adding the load. Right or wrong? How do you increase the load? In the laboratory, how do you increase the load?
Tightening belt.
By tightening the belt, you are increasing the load. Correct. If you want to increase the load, what you will do? We will tighten the belt. When you tighten the belt, okay, current run from the supply will increase. It means that the load on the motor is increased. Right. In the case of fan load, how can you say that the load is increased or the load is decreased? In the case of fan type of load or pump type of load, okay, I can say that the load is increased when the speed increases because the load torque here in the case of laboratory, you will write that torque as equal to, torque is equal to 9.81 into R into S1 minus S2. I think you used this equation, right? What is the torque equation? What is the torque equation? Anyone? What is the torque equation? Are you here? Are you hearing my voice?
9.81 into R into S1 minus S2.
Yes, that is the equation, right? Means that torque acting on the belt drive is proportional to difference of S1 and S2. Okay, R is constant, 9.81 is constant. What is variable? S1 minus S2 is the variable here. Here in the case of belt drive, torque is proportional to S1 minus S2. But in the case of fan load, torque is proportional to when torque is proportional to square of the speed.
Speed.
When the square of the speed, n square. T is proportional to n square. Therefore, when I increase the speed, torque will increase. And again, power. How do you calculate the power? Power calculate చేసేట్టు కదా. With this torque calculation, you will not end. You will calculate the power also. Power equal to 2 pi nt by 60. అలాగే చేసారా? 2 pi n
Yes, sir.
60 is the power, right? Here in the case of the fan load also output power is equal to 2 pi nt by 60 means power is proportional to torque into speed. Okay, now power is proportional to torque into speed. In any case, any motor power is proportional to torque into speed. But torque is proportional to n square. Finally, what we can say? Power is proportional to cube of the speed. Again, I'm repeating again. Here, one minute. Can you see the presentation? White screen.
Yes, sir. Yes, sir.
Okay. Now I'm writing the equations here. Wait, I'm using the pointer. Now torque is proportional to n square. Can you see the things what I'm writing?
No, sir. No,
No, sir.
Hmm?
No, sir.
Torque is
Not
proportional to n square. I wrote. Can you visualize?
No, sir. We can't. No, sir. No, sir.
Okay. I wrote here. Now
Now
can you
it is visible, sir.
Okay, torque
Now it
is
is visible, sir. We can.
okay, torque is proportional to n square. Next. Now power is proportional to torque into speed. Now that implies power is proportional to torque is proportional to n square. Therefore, power is proportional to n cube. Okay. Now can you see that I wrote power is proportional to torque into speed? Hence, power is proportional to n cube. Can you see this now?
Yes, sir.
Yes, sir.
Load. Finally, we can say one thing. Output power is proportional to cube of the speed. When I reduce the speed, what happens? When I reduce the speed, what happens here is the power consumption will also reduce drastically. Okay, now that is the important thing here. But how do you control the speed? To control the speed, we need to go with conventional method. If you conventional methods, nothing but old fan regulators, or if you go for our DC motors for controlling the speed from very closer to zero speeds to above zero speeds, we'll go with Ward-Leonard method of speed control. I will learn this Ward-Leonard method of speed control in DC machines. I will learn this Ward-Leonard method. Ward-Leonard
No,
method
sir.
speed control in our syllabus. Okay, that is the
No, sir.
popular way of. Okay, earlier days it is a popular way of controlling the speed of a DC motor. Now that is not used. But because what do you require there here is you require a DC motor, AC motor, and DC motor. Multiple motors you require for controlling the speeds. Means to control the speed of one motor, you require another two machines extra to control the speeds. Therefore, it will increase the size. Okay, now, but what we require here is we need to get a compact sizes, simple sizes. Therefore, that is not suitable method. Therefore, ultimate aim here is most of the loads are fan type of loads and pump type of loads, either for driving the fan or pumps. In those cases, we can save power by reducing the speeds. Instead of running the pump at constant speed, if I run the pump at low speeds, what happens? I can reduce the power consumption. And here it comes the one of the application of the power electronics. Likewise, I give same examples like electronic speaker control. Next, you will find electric vehicle for charging the battery. Number of examples are there. You can find these examples. Next, power electronic match. Here you will find number of examples are there. You can find these examples. Solar PV system. Here, this is an example of a solar PV system. Next, iPhone's power system. iPhone power system, you will find these many things required. Laptop power system. See that laptop. These many requirements are there. Inverter, buck converter, boost converter. These are the requirements for controlling the display. We require an inverter. For controlling the microprocessor and power management of the desktop, we require a buck converter. For disk drive, buck nothing but buck converter comes under chopper. Okay, boost converter will also comes under chopper. Okay, buck and boost converters will come under choppers. So therefore, we require inverter and choppers for controlling the entire laptop power system. Okay, this is another example. These are the examples of power electronics. Next, we'll go to the next important thing, that is entire power electronics. Even you can understand advanced power electronics also. Because entire power electronics talks about switching. Switching means what? Switching on and switching off. Can you visualize the circuit?
Yes, sir. Yes, sir.
What you find in the circuit is a battery. You can find a battery, a switch, and a bulb. Okay, you'll find these things. I will change the PPT mode. Let us see if it is. Can you visual? Is it now visible? Is it now visible? Yes or no?
Yes, sir.
Okay, good. Now it's very good. Here, I have a battery. Let us consider Vs is the battery voltage. Okay, let us consider Vs is the battery voltage. And let us consider VL is the load voltage or voltage across the bulb. And let us consider switch voltage as VSW. Now, can you see what I'm writing?
No, sir. No, sir.
Are you not able to see what I'm writing on the presentation? You are not
No, sir.
VS,
No,
VL.
sir. No, sir. No, sir.
Okay, no problem. Okay. Now I have written. Now you can see now. I think you can see now. Yes. You can
Yes,
see
sir.
right. Yes,
Yes, sir.
VSW, PL. Okay.
Yes, sir.
Now can you see VS, VSW, VL?
Yes, sir. Yes, sir.
Yes. Okay. Now let us consider VS is the battery voltage. VSW nothing but switch voltage. SW and switch end. Okay. VSW is the switch voltage. VL nothing but load voltage or the bulb voltage. I think you know the switch. We know the operation of the switch because we are using the switch from your childhood days. What happens when I turn off the switch? Bulb will glow or bulb will not glow? Okay, if I ask these questions, I'm stupid. Okay, everyone knows. Therefore, if I turn off the switch, bulb will not glow. If I turn on the switch, bulb will glow. Or I will ask in a typical way, why the bulb is glowing? But if I turn on the switch, why the bulb is glowing? What is the bulb voltage? What is the load voltage? If I turn off the switch, what is the bulb voltage and what is the switch voltage? Okay, these are the questions. I'm asking you the questions. I will come with the answer. Okay, I will tell you because this is very simple. When I turn on the, let us consider when I turn off. When I turn off the switch, the bulb is not glowing. The bulb is not glowing because
Open circuit, sir.
it is open circuited. Current will not flow in the bulb. Output voltage is zero. Don't talk about the current. Talk about in terms of the voltage. I want in terms of voltage. Okay. When I turn off the switch, load voltage is zero. That's why the bulb is not glowing. Okay, now. If the load voltage is zero, what is the switch voltage? Anyone? What is the switch voltage? What is the voltage across the switch?
Supply voltage.
Supply voltage, yes. That is clearly written here. Second case, when the switch is in off condition, okay, the bulb will not glow because the bulb is not glowing because voltage across the bulb is zero. Since the voltage across the bulb is zero, the entire battery voltage or the supply voltage will appear across the switch. That's why the switch is not glowing. And if you see that, what is the current, load current? Load current or the switch current? Switch current, what is the current passing through the switch or the bulb? Zero. When the switch is in off condition, okay, when the switch is in off condition, when the switch is in off condition, switch voltage is equal to Vs. I wrote on here, okay, I highlighted. Can you see the highlighted thing? Switch voltage is equal to Vs. Switch voltage is equal to Vs. Load voltage is equal to 0 and switch current or the load current is equal to 0. Now can you see the highlighted thing? Can you visualize the highlighted things? I highlighted with yellow color.
No, sir.
No problem. Again, we'll go back and see.
Sir, we can see, sir.
Okay. Okay, we can visualize, right? When the switch is in off condition, switch voltage is equal to Vs. Keep on mute. Switch voltage is equal to Vs. Load voltage is equal to switch current is equal to 0. Okay. Now let us take the other case. When I turn on the switch. When I turn on the switch, what happens is the bulb is glowing. Okay, now when the bulb is glowing, why the bulb is glowing? Because the battery voltage or the supply voltage is appearing across the load. So that when the switch is on, load voltage is equal to Vs. Load voltage is equal to Vs. Switch voltage, what is the switch voltage when the switch is on? When the switch is on, switch voltage is equal to 0 because it is earlier
Short
the switch
circuit.
is circuited, now the switch is in open circuited condition. Okay, earlier it is open circuited, now it is in short circuit condition. Since the switch is in short circuited condition, switch voltage is 0. Okay, switch voltage is 0. And if you find the switch current, what is the switch current? Nothing but the load current because both are connected in series. Therefore, when the switch is on, the switch current depends upon the load. For example, if I keep a 60-watt bulb, you will get one value of current. If I keep a 100-watt bulb, you will get another current value, a higher current value compared to the first one. Means when the switch is on, the current passing through the switch is decided by whom? When the switch is on, the current passing through the switch is decided by the load. Okay, na? Are you getting my point or not? When I keep a 60-watt bulb, it will draw one current value. When I connect a 100-watt bulb, it will connect another value. For example, if I connect a heater, 1 kilowatt heater or iron box, if I keep a 1 kilowatt iron box, what happens? That it will draw a very high value of current. Therefore, when the switch is on, the switch current is decided by what? Load. That's why switch current is equal to load current. Okay, switch voltage is equal to 0. Under this condition, load voltage or output voltage is equal to supply voltage. Understood these points? Understood these two cases? Did everyone understood these two cases? Yes or no? When the switch is on and the switch is off. Yes or no?
Yes, sir.
Yes.
Yes, sir.
Yes. That if you understand this means what? You understand entire power electronics. Except first unit talks about characteristics of the switch. Except first unit, you can understand the remaining 3 units. Because the remaining 3 units we are discussing about these two cases only: switch on and switch off. Okay, entire power electronics, except the characteristics of the switch. Okay, except the characteristics of the switch. Except the characteristics of the switch, entire power electronics talks about switching on and off. Okay, but what is this example you have taken is a mechanical switch. It is not a power electronic switch. What is the switch you have taken? See the switch. What is the switch you have taken? A mechanical switch. Means switch use it for controlling the fan. Switch use it for controlling the bulb. But in our power electronics, instead of this mechanical switch, we'll go with power electronic switches. Okay. In our electronics, you learned about diode. Okay, diode is one switch. BZT is one switch. Mosfet is one switch. Now we can use this BZT as a. We can use BZT as a.
Sir, not audible.
I think you can hear my voice. Uncontrolled switch is nothing but a switch. As I said, no example is a diode. When I give a positive voltage to the anode, negative voltage to the cathode, what happens to the diode? Diode turns on. When I give a negative voltage to anode, positive voltage to the cathode, diode goes to off. Means there is no control. Depending upon the supply voltage polarity, the diode is going on and off. Means it is called as an uncontrolled switch. Okay. Next one is a next classification is a semi-controlled switch. This is a very typical switch, and most of the power electronics we are discussing about this switch, this semi-controlled switch. Example is called as silicon controlled rectifier. We'll talk about this later. Here, what I can do here is, here I have a control called as a gate. With the gate voltage, you can control, you can turn on the switch. But with the same gate voltage, you cannot turn off the switch. With gate voltage or current, take any either of the two cases, either voltage or current. With a gate, with another control voltage or control current, okay, we can turn on the switch but not turn off the switch. That's why it is called as a semi-controlled switch. If you understand this fully controlled switch, you can better understand semi-controlled switch. Fully controlled switch example is Mosfet or BJT. What are the terminals of the BJT? Emitter, base, and collector. Okay, emitter, base, and collector. Let us suppose that I connected a DC supply between collector and base, collector and emitter, and the load between and the load is connected to the emitter as well as the negative of the battery. Now, it is nothing but now BJT is acting like a switch here. Now, one more terminal is there, nothing but the base. If I give the base current, this BJT will turn on. If I stop the base current, BJT will turn off. Means who is controlling the switch? Okay, between the load and supply connected a BJT. Okay, collector and emitter. But base is there, no third terminal base. This is the controlling point. Here, therefore, if I give the base current, what happens? The switch will turn on. If I stop this base current, switch will turn off. Means on and off is there in my hand. By giving the current, by controlling the base current, I can control the switching action. I can do both on and off with the base current. That's why it is called as a semi-controlled switch. Sorry, it is called as a fully controlled switch. Because with the base current, I can do both on action as well as the off action. Okay. But in the case, if you go for another example, Mosfet, what are the terminals of the Mosfet? Terminals of the Mosfet, anyone?
Source, drain, and gate.
Source, drain, and gate. Yes, okay. Source means what? Will connect this source. Nothing but DC supply. DC battery. Drain means what? We are using the power. Nothing but the load I will connect between the drain. Okay. Now there is another terminal called as the gate. If I give the gate voltage, MOSFET will turn on. Are you getting my point or not? I'm connecting a MOSFET in between a battery and a load, nothing but a bulb. Now I have a MOSFET here. Now there is a third terminal called as the gate. By giving the gate voltage, I can turn on the switch. Okay, if I make the gate voltage to 0, this MOSFET goes to off state. Means gate voltage is used for controlling the on and off action. By controlling the gate voltage, I can do both. Okay, I can control both on action as well as off action. That's why it is called as a keep on mute. ఎవరో చెప్తున్నారు మ్యూట్ లో పెట్టండి, మ్యూట్ చేయండి. ఎవరమ్మా మ్యూట్ లో పెట్టకుండా వదిలేశారు? You are not attentive as well as someone. That's why I'm asking the questions. Some people are not attentive. That forgot to keep on mute. Elbear. No noise is coming and disturbing the class. That's why I will ask questions. Okay, now I think you understood what is this fully controlled switch, semi-controlled switch. With this class, with this, I'm going to end this class. In today's class, you learned about very important thing, that is switching behavior, properties of the switch, and types of switches. Okay, 1 minute. Keep on hold. Will take the attendance. Be attentive. Okay, na. Try to keep on mute as possible as well. Okay, after answering the answer, try to keep on mute. One minute. Taking the attendance.